Okay, so we've talked about relative frequency probability and we've talked about theoretical probability. There is a third kind, and it is called subjective probability. And it is an estimate based on experience or intuition. Sometimes this is a little bit hard to distinguish because of the way it's phrased, but it should be fairly obvious. For example, you can make a subjective estimate as to the probability a friend will be engaged within the next year, or of how happy you will be purchasing a certain model of a car. Okay, those are a couple of examples. But again, it's just based on an intuition or experience. Okay, so let's look at 3 different scenarios and assume that you're rolling a fair die. Identify each method reflective in the following statement as either relative frequency, theoretical, or subjective. Okay. I am certain that you will roll a 4. That's a hunch, that's an intuition, so that is going to be subjective. After 20 rolls, the die lands on the number 4 a total of 5 times. According to this data, what kind of probability of rolling a 4 is 5 out of 20 or 1/4? Okay, well, it's based on this data, and that means it is a relative frequency. Okay. And lastly, we have what kind of probability of rolling a 4 is 1/6, because there are 6 possible numbers on which the die can land and only one of them is 4. Well, we just worked with that. That, of course, is going to be theoretical probability. Okay, so this will just get easier as you look at it. And again, we'll continue to talk about it. Okay, so let's talk about the probability of an event not occurring. Okay. The probability of an event not occurring. If we know what the probability of something occurring is, then we can figure out what the probability of not occurring is. The probability of not A is 1 minus the probability of the event occurring. Okay, so let's go through this and see what we can do. Alright, so consider you're rolling a fair 6-sided die. Write the probabilities as fractions. So what is the probability that you roll a 3? Of course, that's a theoretical probability. There is 1 opportunity out of 6 possibilities. What is the probability that you do not roll a 3? Well, that's either a 1, a 2, a 4, a 5, or a 6, which means that there are 5 possible ways out of the 6 equally likely outcomes. Okay, so let's add these together. So if we take our 1/6 plus 5/6, and you can either do this on your calculator or recall what the rules are for doing this. And you will see that if you do it the old-fashioned way, that's 1 plus 5 over 6, which is 6 over 6, which is 1. Okay. Now, why does it work like that? Well, why do they add up to 1? Well, each roll is either a 3 or it's not a 3, which means that rolling a 3 or not a 3 is a certainty, so the probabilities have to add up to 1. So let's phrase that a little bit different and shorten it a bit so it'll actually fit on this page. So each roll is either a 3 or not a 3. So it is certain, and here's that word again, that one of these options will occur. Okay, so let's see how we can do this. So I could easily have also found this. I could have found that the probability of not a 3 is 1 minus the probability of a 3, which is, and I didn't leave myself enough space here, 1 minus 5 over 6, which is still 1/6. I'm sorry, 1/6, which is 5/6. Okay, so you can do it one of two ways. All right, so let's do some more practice now. For each of these situations, find the requested probability, then identify the type of probability. If today's forecast predicts a 0.37 chance of rain, what is the probability that it will not rain? Okay, well, if we're looking for when it will not rain, we can say that the probability of not rain is equal to 1 minus the probability of rain, which we know. So this is 1 minus 0.37, which is 0.63. Okay, now what kind of probability is this? Well, it doesn't say how they arrived at it, but if it's a forecast, then that pretty much falls under the category of subjective, which is experience or intuition. So we are going to say that this is subjective. If I could argue that if it's based on data, then it could also be a relative frequency. Okay, referring to the standard deck of 52 playing cards, what is the probability that a single card selected at random is not an ace? Okay, well, let's see here. The probability of not an ace is 1 minus the probability of an ace, which is 1 minus 4 out of 52. Now, if we're doing this the old-fashioned way, then we know in order to add and subtract fractions, we have to have a common denominator. Anything divided by itself is 1, so this is going to be 52 over 52 minus 4 out of 52. That's 52 minus 4 over 52, which is 48 out of 52, or 0.92. Now, there's no data here, there's no hunch. This is just theoretical probability. Okay, based on her performance during a recent season, a player has an 80% chance of making a free throw. What is the probability that the player will miss a free throw? Okay, well, we can say that the probability of not a free throw is 1 minus the probability of making a free throw, which is 1 minus, and of course we'll have to take that and turn it into a decimal, which is 0.20. Okay, now let's see. Is it relative frequency, theoretical, or subjective? Well, it's based on the data from the prior season, which means this is relative frequency. Okay, now we're rolling a 12-sided die. what is the probability of rolling a number larger than 5? Okay. So, the probability of larger than 5 is the same thing as the probability of a 6, 7, 8, 9, 10, 11, or 12, which means there are 7 ways of getting a larger than 5 over the 12 possibilities, which is 0.58. All right, what is the probability of not rolling a number larger than 5? Well, there are 2 ways of doing that. We can find it. So the first method, the probability of not larger than 5 is 1 minus the probability of, and I'm going to greater than 5, which is 1 minus 0.58, which is 0.42. Now there is another way to do it. Since we know that there are a finite number of possibilities, the second method is the probability of not greater than 5 is the same thing as the probability of a 1, a 2, a 3, 4, or 5, which gives 5 out of 12, which is also 0.42. Okay. All right, so let's see. You roll a die, a 6-sided die, 10 times and it lands on a 5 6 times. You roll the same die another 500 times and it lands 90 on a 5 90 times. Do you think the die is fair? Okay, well let's look at the theoretical, the relative frequency. So for the small sample, we had six out of 10, which gave us 0.60. We had it landed on a 5 6 times out of 10 rolls. Okay. Then the large sample. Well, we knew we had 500 rolls and it landed on a 5 90 times. That becomes 0.18. Well, let's compare those now to the theoretical. Well, it should land on a 5 1 out of 6 times, which is 0.17 as a percent, or excuse me, as a decimal. So do you think it's fair? I do. Yes. The large sample is close to the theoretical. Okay. Now our last topic for part 1 of 7a deals with probability distributions. Okay. Probability distributions list all the probabilities of all possible events. Okay. So no matter what could happen, you can look at this distribution, this probability distribution, and find out what the probability of a particular event is. Okay, so the first thing you're going to do when you do this is you're going to list all the possible outcomes as some kind of a systematic list. And this will go back to your what we did in the very first unit about making systematic lists. Identify the outcomes that represent the same event and find the probability of each event. And then make a table that displays all the probabilities. And this is really important here, is that the sum of the probabilities must be 1. Okay, so if we're looking at a probability distribution, the sum of everything has to be 1. Okay, so let's see. We're going to follow the steps, and we're going to create a probability distribution table for all the possible outcomes for the number of girls in a family with 3 girls. And we're going to assume it's either a boy or a girl. Okay, so we want to list all the gender combinations for a family of 3. Well, we know we've got 3 kids, and we've got 2 possibilities for each choice. So let's look at the outcomes. So the first thing we're going to do is look at all the possible outcomes. Okay. So that's what we're going to do here in the first one. We are going to look at the outcomes. All right, well, we're going to break this up into a first child, a second child, and a third child. Okay. So we know our first child, we're either going to have a boy or we're going to have a girl. All right, then from there, we know that our second child can either be a boy or a girl. Boy or a girl. Then we know for our third child, once again, it can either be a boy or a girl. Okay, now we can look at all of the possible combinations. We still haven't made our list. Okay, but we have the combination. We can have a boy, a boy, a boy, 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 girl, boy, girl, boy, boy, girl, 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 boy, boy, girl, boy, girl, 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 boy, and girl, girl, girl. Now we can go back to the multiplication principle and verify that we have 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. Well, for the first child, there are 2 choices, a boy or a girl. 2 choices for the second, and 2 for the third, which means there are 8 equally likely outcomes. Okay, then we are going to have to look at the events. Okay. So we're interested in sorting the total possible gender combinations for a 3-child family based on the number of girls in each combination. There are 4 possible events based on the number of girls in a 3-child family. You can have 3 girls, 2 girls, 1 girl, or no girls. Okay, so now we are looking at the events. So we are going to, if we want to find the probability of one of these events, either the 3 girls, 2 girls, 1 girl, or no girls, we are going to look at the probability of that event divided by the total number of equally likely outcomes. So from all of these, we're going to be dividing by 8, which is the number of outcomes. equally likely outcomes. Okay, so let's look at the possibility, the number of ways the event can occur. If we're looking at 3 girls, whoops, excuse me, there's only one way that can occur, is if it's a girl, girl, girl. If we're looking at 2 girls, then we're going to look at, no, this would be, there's 1, there's 2, there's 3. So 1, 2, there are 3 ways that that event can occur. The possibility of 1 girl, there's 1, 2, 3. 3 events that allow that to occur out of the 8 possible outcomes. And no girls, there's only 1 way for that to happen. Okay, so now we're going to fill out our table. The number of girls, these are our events, 3, 2, 1, 0. And then we have to fill in the probability of each of these. So the probability of 3 girls is 1/8. Of 2 girls is 3/8. Of 1 girl is 3/8. Of 0 girls is 1/8. And if you total those all up, since they all have the same denominator, that's 1 plus 3 plus 3 plus 1 over 8. Which is 8 over 8, which is 1. Whoops, and I'm sorry you couldn't see that. Okay. All right. Well, let's do some more of these. I'm wondering if I should switch videos. Yeah, I think I will. And then we'll do the last 2 and I won't feel rushed.